deadly with his words and his gun, right? Yeah. All right. Hope that you are ready to go. I'm looking around. I see lots of, look at all you guys. You guys are on it. We're going to continue talking about factoring, right? So this chapter is all about factoring. So the good news is that you all did quite well with your quiz, and so a lot of the skills that we're about to use are going to be things that you're probably going to be really good at. We're going to be just doing a little bit something different with it. We're going to introduce a new term, and that new term is quadratic. Yeah, so we're going to be solving quadratic equations by factoring, and we talked about this at the start of the year. I want to talk about it again. I think the word solve is a very overused word. I think we think about, why don't you think about this? Starting in like elementary school, maybe middle school a little bit, the word solve is often used to describe doing something, right? So in other words, like, okay, I've done some work with some math. I solved it. Figuring something out, or even sometimes solve is used in place of simplify, right? Like I've seen things like this where there's maybe like x parentheses x plus 2, and I say simplify, like the instructions say simplify, and so somebody maybe does the distributive property and they get x squared plus 2x, and their commentary at the end is, I solved it. No, you didn't. You didn't solve anything. The only thing that you can really solve is an equation. The only thing you can really solve is an equation, because you're getting a solution to make the equation true. In this case right here, there's no equation to be solving. So the only thing anybody really did ever with that is to simplify it. So I think this is an important thing to bring up, because for the first time this chapter, this symbol has not appeared once in this chapter, yet this symbol appears on this page twice. What symbol am I talking about?
Equal.
The equal sign, that's right. So this thing right here has not showed up once, I don't think, in this whole chapter until right now. And so we are going to be talking about how to solve these quadratic equations. So a quadratic equation is defined to be this right here. Any equation that can be written in the form ax squared plus bx plus c equals 0. So what is the degree of a quadratic equation?
4.
Degree would be 2, right? Because you're looking at the degrees on the variables. So the x's of the variables here, a, b, and c, those are defined to be constants. So like a could be, we've done this before, right? A could be 3, and b could be -7, and c could be 12, whatever it happens to be. So a, b, and c still stand for those constant numbers. So the degree is 2, and you could have, with a quadratic equation, you could have 3 terms. You could also have just 2 terms. You really could have 1 term as well, but the degree has to be 2. Okay, so ax squared plus bx plus c, that's what we call the standard form of a quadratic equation. So the degree is 2. Let's take a look at some examples of quadratic equations, and we want to try to identify a, b, and c in each of these. So in this first one, I'll just write it down here. What do you guys think the a value is?
1.
The a value is 1, because a is the coefficient on x squared, and right now it's just x squared, so it's implied to be 1x squared. How about the b value? 2, that is right. That's the b, and the c is?
-24.
That's right. It's not 24, it's -24, like you all said. Okay, so that's a pretty basic example. Let's take a look at a couple of others. Keep flipping on down. Good question. Okay, so then, 2 more here. X squared minus 64 equals 0. 5x squared plus 45x equals 0. Why don't you guys try those 2 right there? Let's see if you can write down for both of those the a, the b, and the c values. Give you just a brief moment to do that. All right, Alec, how about the a value in this this one right here? I agree, a is 1. Jake, how about the b value for this one? No idea. Hunter, how about the b value in that second one?
0.
0 is correct. Let's talk about why. So ax squared, so the a is the coefficient on x squared. B is the coefficient on x, and if you look at this one, there is no x term, is there? There is no x term. There's no x squared plus 5x minus, it's just not there. So if it's not there, then the b has to be 0, because the x has just sort of disappeared. The only way to make something like that disappear is to multiply by 0. So b has to be 0. Jake, does that make sense? Jake, how about the c value? What's that?
-64.
Okay. What do you guys think? Any questions? Okay, awesome. Colby, how about the last one there? What's your A value?
5.
I agree. Sam, how about your B value?
45.
Avery, how about your C value?
0.
That is correct. Notice how there does not appear to be a C. That's because it's plus 0, so we probably would not bother to write that. Do you guys have any questions about that one? Okay. So I want to talk to you guys for just a second about what, in my opinion, is one of the most important numbers that there is. I think that there are 4 really important numbers that are used all the time and are really crucial for our structure of mathematics. You guys know 3 of them. I think the really important numbers are 0, 1, pi, and then later on you'll learn about a number called e. That'll come in like algebra 2, I think. You guys know about 0, 1, and pi. I think one of the most important things about 0 is this. Any real number times 0 is what? 0. That's a really crucial factor because no other number has that property. No other real number has the property of anything times that number is 0 or any other particular number. So when you think about this, this is going to be particularly useful as we try to solve these quadratic equations. So the key is what we call the zero factor property. I will often abbreviate the zero factor property with the letters ZFP. Obviously, zero factor property, the acronym for that. And here it is. The principle is this. If A times B equals 0, not A plus B or A minus B, but specifically A times B. So if A times B equals 0, then either A is 0 or B is 0 or perhaps both, right? So if you have 2 numbers being multiplied together and the answer is 0, then either one of those 2 numbers is 0, maybe even both, right? That's going to be the key property for us. Zero factor property being any number times 0 is 0, okay? There's no such thing as like the 12 factor property because any number times 12 is not necessarily 12, but any number times 0 is absolutely, definitely going to be 0. So we'll do a couple of examples here and we'll head to the board. So let me get there. Oops, how about that? There we go. Let's do numbers 1 and 2 together. So with a problem like number 1, a question like number 1 here, I want you guys to notice something really important about this. What does it look like somebody has already done for us in number 1?
Factor complete.
Look like somebody's already factored this, right? How do we know that somebody has already factored number 1?
In parentheses.
And?
You could FOIL it.
There's 2 terms.
What?
You could FOIL it.
You could FOIL it because it's a multiplication, right? So the left side is, you're right, you FOIL it. The left side is something times something. Contrast that with number 2. Is number 2 something times something? No, it's something minus something else. And so number 2 has not been factored. Number 2 is not a multiplication problem, but number 1 is. So it's really important that we notice that there's a difference between multiplication problem and a non-multiplication problem here. Because remember, the zero factor property is this. Any number times 0 is 0. Not any number minus 0 is 0, or any number plus 0 is 0, specifically times. And so with a problem like number 1, what we already have is this. If you think back to the zero factor property, don't we already have A times B equals 0? Isn't that kind of the scenario here? We have something times something else equals 0. So here's what we do. Here's how we use the zero factor property to help us solve this. If I've got something times something else and the answer is 0, I set each of the factors equal to 0. So this is the zero factor property right here. Bless you. So I'd set each factor equal to 0. So x plus 11 equals 0. 7x minus 4 equals 0. Because I know that if I have 2 things being multiplied together and the answer is 0, then either the first factor is 0 or the second factor is 0, or possibly they're both 0. So I have to take care of all those cases. And once I've done that, I just solve each of those equations. So with this one here, the first one, I would subtract 11 from both sides. So my first solution would be x equals negative 11. My second solution, I would add 4 to both sides. And then I would divide both sides by 7. I would get x is equal to 4/7. So this particular equation has 2 distinctly different answers, both of which make the equation true. How could you check to see if these solutions... Yeah, just plug them in. So check it out. If I decided to do a little check off to the side here, I could try out, say, the negative 11. I would go negative 11 plus 11 times 7 times 11 minus 4. Whoops. Yeah, Rocky, I can kind of tell. So I'm going to give you a chance to ask a question in a second. Equals 0. What's negative 11 plus 11?
0.
And 7 times 11 is, 7 times 11 is 77. That's minus 4. Really doesn't matter. 73, though. What's 0 times 73? So do you see how negative 11 made that a true equation? So I'd say that checks. You could also do the same thing with 4 sevenths. So that would be 4 sevenths plus 11 times, it'd be 7 times 4 sevenths minus 4 equals 0. Well, I don't know what 4 sevenths times 11 is off the top of my head, but I do know over here the 7s would cancel, and I'd get 4 minus 4, wouldn't I? Which is 0. Anything times 0 is 0, so I get 0 equals 0. This checks. So what we're trying to do is we're trying to find solutions that make the original equation true. Okay, so Rocky, do you have any questions I can help you with, or are you just going to stand by your statement of, I'm confused? You can give me something, a little something to work with, like, I don't get this. Be specific. I probably can work with you. I'll let you think about it while Danny asks hers.
So would either of those answers work?
Yes, and didn't I just prove that?
Okay,
So-
it's like if on like WebAssign you entered negative 11.
You have to enter both. You have to give both answers. Yep. So with quadratic equations, the possibility of getting two completely different answers that both work is very likely, and it will happen often. Sometimes they'll only have one answer, to be honest with you, but very frequently they'll have two answers, and so you'd have to supply both, and they both should work.
So is that what you want like on the quiz?
Yeah, you got to give both. Yep, great question. Sam, go ahead.
So, say we had like x equals negative 11, which works.
Yep.
Then we had like x equals 3 sevenths, and say like that didn't work, then we would just...
Now, did you get the 3 sevenths through like some faulty algebra, or did you do all your algebra correct?
No, I was just like giving like...
But that's what I'm saying, like in your scenario, did you get the 3 sevenths from like a faulty algebra step, or was it like, was all your algebra good and you just got this answer? That's what you're saying, the second scenario?
Yeah, saying that like if one x
Yeah.
is correct and the other isn't.
It shouldn't work out that way. If you do your algebra correct,
So
both
that-
answers should check.
Okay.
They should. Yep. So I would say along those lines, if you do check and one of them doesn't work, go back and recheck what you did to get that answer. You might find an error.
So like you'll never have one right and one wrong.
Not in
For
this,
us.
not with the, well, not with these equations. Not with these types of equations. Not with quadratic equations, no. If your algebra is true, then both answers, if you get two of them, should work.
Okay.
Yeah, it should work. Amelia, go ahead.
So when you say like A times B equals 0 and 1 has to be 0, you're talking about like A or B, this is that entire phrase in parentheses, right? It's not.
Yes, yeah. So like in this case, A would stand for x plus 11.
Okay.
So yeah, so A just stands for some quantity, some number, some variable, large or small.
Okay.
B stands for something similar. Yeah. Great questions. Rocky, we're back around to you. Do you have anything you want to ask? These have been really insightful questions.
I think I'll just keep watching.
Okay. Jake, go ahead.
You're basically just solving for x.
Yeah, trying to find a solution for x that makes the original equation true.
In this case, there's just a handful of solutions.
Yeah, there's two. Yeah. So maybe I should put it like this. Maybe, to address your question a little bit further. I'll just do this down here in this little corner. Like you guys remember, I'm sure, because you did it probably last year and you did it this year. You remember these old equations where it's like 10x minus 20 equals 0?
Yeah.
What instructions usually accompanied something like that?
Solve for x.
Solve for x, right? And so if we're going to solve for x, you would add 20 to both sides and you divide both sides by 10, you'd get 2. And so with these quadratic equations, our goal is still the same, right? Our goal is to find a value for x that makes the equation true. But because it's a quadratic and there's like its next squared, we have to use different techniques, right? It's a little more of a complex situation, so the same old techniques don't really work the same way. And so you can't use those. You got to use a little bit different. Okay, so let's do another one here. Let's do number 2. Please, you're asking great questions. Please keep asking them as they come up for you. So here we go. Let's take a look at number 2. In fact, here, let me give myself just a little bit more room here with number 2. Okay, so we're going to solve. And this time when I look at this equation is definitely not a product, is it? It's x squared minus 3x minus 40. So in its current form, that whole zero factor property thing does not work. Because those are not factors, right? Because it's not a multiplication problem. So this is a big transition for us. If we want to have a multiplication problem, but we don't have one, how do we take something that's not a multiplication problem and turn it into one? You factor it. That's what we've been practicing. So we need to factor it, and here's our factoring strategy. We're going to look at this and say, awesome. Is there a GCF? There's no GCF. Okay. How many terms are there? 3 terms. Is the A value 1?
Yeah.
It is. So if you want to use that diamond method approach, which I think we're starting to come around on, or the 2-column thing, it's up to you. Our C value goes here. Our B value goes there. We start to think, all right, which numbers multiply to be negative 40?
Negative 8 and 5.
And that's right. Those had to be negative 3 as well. So negative 8 and 5. So what I can then do is I can take that quadratic equation that I have right there, and I can factor it like this. X minus 8 times x plus 5 is equal to 0. This is a big deal because we've gone from something that was not a multiplication problem to now it is. That's what factoring does. And so, because that is now a multiplication problem, if I want to solve this, which is what the instructions were, I can now use the zero factor property because I have factors. So the zero factor property tells me this. If I've got 2 factors and the product is 0, then I can take each of the factors and set them equal to 0 and solve. So, to set the factors equal to 0, I would write x minus 8 equals 0, x plus 5 equals 0. It's an important thing to show that zero factor property step. All right, and of course these are really easy equations for you guys to solve. You add 8 to both sides, so x equals 8. You subtract 5 from both sides, x equals negative 5.
I got it.
Those would be your answers to solve this equation. Those would be your solutions. Question, yeah, go ahead.
So you don't have to go x squared minus 8x plus 5x minus 40. You don't have to do that for.
You could.
I just don't understand like why.
Oh, you're talking about the split the middle thing?
Yeah, I don't understand.
So when your A value is 1,
Oh, yeah, maybe that's one, I guess.
but when your A value is not 1, then splitting the B is what
Then
you
have to split-
think about doing.
split the B.
Yep,
Okay.
yep. But when your A value is 1, you don't.
Okay.
Yep, good question. All right, speak up if you've got another question of any kind. Okay. I hope you'll find number 3 to be set up similar to what you just have been doing. Number 4 is a little different, so you probably can do it, but I might need to give you a little bit of help when it comes down to it. So take a few minutes, try 3 and 4, see how it goes, and we'll analyze what we need to in a minute. So with number 3, x squared minus 100 equals 0. Remember the goal here is to solve for x, find the solutions for x that make this equation true. And so you look really carefully at this, and it's a quadratic, and then not only is it quadratic, it's kind of in standard form. It's not factored, is it? It's not something times something else, it's something minus something else. And so what we need to think of is, how can I turn this into factors instead of being a difference? That's the question is really the process of factoring. So we look at this in terms of like that little flow chart that I showed you. So for number 3, is there a GCF?
No.
There's no GCF. How many terms? 2. So if it's 2 terms, the big question after that is it the difference of squares?
Yes.
It is. It is the difference of squares. And so this will factor with that plus minus pattern. And so this would factor as x plus 10, x minus 10, and it would still equal 0. Did you guys get that factoring okay? Factoring of the difference of squares? Once you've factored it, now you can use the zero factor property. So with the zero factor property, what you do is you set each factor equal to 0. So that would be x plus 10 equals 0, or x minus 10 equals 0. You take those two equations and you solve them. This one by subtracting 10 from both sides. This one by adding 10 to both sides. You have two answers, x equals negative 10 or x equals positive 10, both of which make the original equation true. Yeah?
I'm just wondering, if I write this on a test, would I get it wrong? I said x equals plus or minus 10.
Absolutely correct. Yep, we'll go there soon. Yep, plus or minus 10. Now, have you guys all seen that symbol? Yeah. Plus or minus. Keep in mind it's not plus and minus, because that's impossible, right? It'd be plus or minus. It's an important distinction. I don't know what plus and minus, that's,
Plus and minus would still be.
I don't know. Okay, so finally number 4. Number 4, we start to dig a little deeper, starting to head into the territory where we'll go tomorrow. So with number 4 is not written in standard form. Remember, standard form for a quadratic is ax squared plus bx plus c equals 0. So, do you guys see equals 0 here? So we want to get to kind of our home base. Our home base is standard form, which is equals 0. So what could I do to turn this into that?
Minus 45x.
That is exactly what we've got to do. So it'd be 15x squared minus 45x equals 0. So that's now in standard form, so that's really great, but it's not factored yet, right? It's not in the zero factor property format. And so we got to go through our factoring. So Christiana, is there a GCF?
15.
More than 15, actually, a little bit more.
15x.
15x. It's really important that we factor the x out of
Wait,
here.
I'm kind of confused.
Yeah, go ahead.
Why would you, if there isn't, 0 is still part of the equation, right?
Yeah, right here. Oh, you're talking about the c.
Yeah.
It is. Yeah, I agree.
How can you pull 15x out of 0?
Because what you're doing is you're dividing. Well, when you factor out, or like when you take the GCF out or pull the GCF out, what you're technically doing is you're dividing that out. And so to say, what is 0 divided by 15? It's still 0. So you can divide a 15 out of 0, just the remainder, the leftover would still just be 0. That's actually a pretty good deep question. I like it. Just remember that GCF factoring is really just a division. You're dividing something back out. Okay, so are you guys all okay with Sam's idea that the GCF is 15x?
Yep.
Any questions there? Got to write the leftovers. So if we take that 15x out, we're left with x minus 3. I agree. Okay, so now we're in a really good place because we have now created factors, so we can use this zero factor property. The zero factor property tells us that if we have two factors and the product is 0, we can set each factor equal to 0. So that's what I'm going to do. I'm going to say 15x is equal to 0. X minus 3 is equal to 0. So I'll bring these up here. 15x equals 0. Wouldn't we just divide by 15? So 0 divided by 15, we get x equals 0. And we take this one up as well. I would just add 3 to both sides. So I would get x is equal to 3. Awesome. Looks really good. A question? Yeah, go ahead.
I'm a bit confused why you had to solve for 15.
Yeah.
Now, wait a minute. Solve for
No,
15.
I thought x equals 415 because I thought it was outside the question. Because it's outside
Now, wait a minute. I'm just listening very carefully to your words, and I think we can maybe help you with that. With your question, think about your words. You said, I don't understand why we have to, say it again.
solve x 15.
Solve x.
Solve,
Say it again.
solve x. Oh.
Do you see why I'm starting to trip up on your words a little bit? Like,
Yeah.
solve x for 15, or,
Yeah.
So what I'm looking at here is this step is key because going from the previous step to that one, I've factored, right? I've gone from something that's not a multiplication problem to something that is, and I know the product is 0. And so the zero factor property tells us that if I've got a product of 2 or more factors, and the answer is 0, then I can set each of those factors equal to 0. The truth is, 15x could be considered a factor on that left side, right? And so I would take that factor, 15x, set it equal to 0, and decide, all right, what value of x works there?
Okay.
Dividing by 15 allows me to see that x equals 0 is what the solution would be.
Okay.
Did I answer your question?
Yeah, that makes more sense.
I really try, like when somebody asks a question like that, I really try hard to listen, and I was listening and I was getting confused. And I think you kind of cleared up a lot of your thinking. Listening to, am I right?
Yeah.
You did a good job, like just you're like, okay, I don't know if I'm making sense. But does it make sense to you now?
Makes sense now, yeah.
Okay. Any other questions? Okay, let's finish off today with this. I'm sorry we're not going to get to the board today. I intended it for us to do that. We'll start tomorrow off with seeing how much you remember. Really sorry. Can I talk to you real briefly about what I would expect on a quiz? We'll keep reinforcing this, okay? So let's say that this very question, number 4, was a quiz question, and you're doing your best to do this right? Show that you know what to do. So here would be the steps that I would want to see. Definitely want to see this factoring step right here. This factoring step is really important. You won't always have to do this. You won't always have to get to that standard form. Sometimes it'll already be in standard form. But whether it is or isn't in standard form, you need to get there and you need to factor it. So I'll definitely be looking for this factoring step. Also, something really important for you guys to be aware of, I'm going to be looking for this zero factor property step. I want to see where you set each factor equal to 0 and solved. You'd be amazed at how many really smart, careful people get a little bit careless. They don't show that, and that causes them to get the wrong answer. Not because they don't know what to do, they just get careless, right? And so you want to, definitely want to show that step. Some steps I don't really care about, and this is different from first semester, so I think you should know this. I am well aware that you guys know how to add 3 to both sides. You've shown that you can do it. I'm well aware that you know how to divide both sides by 7 or 15 or 22 or whatever it might be. So all those little steps that, hey guys, all those little steps that, in the past I've said, hey, you got to show this and you got to show this, the +3 stuff, all that. I know you can do that, so if you want to show that, that's great, but I'm not going to go through and be like, oh, you didn't show that. That was kind of a first semester thing to make sure you know what you're doing. At this point, I'm not as concerned. So hopefully you'll do that well. Quadratics, part 2, tomorrow. Have a great day.